Okay, so in this video we're going to look at derivative exponential functions, more specifically e to the exponent x. So it looks like this. So e is a special irrational number, and it's kind of like pi. So it has an approximation of about 2.718, and I would encourage you to go to your calculator and find your button. You do have a button. Should look like that, and it should have that exponential base e on there. Okay, so again, this video is a tutorial on how to use the definition to find a derivative of these functions. It's not like in a classroom setting where you would discover, you would prove it, you would look at the diagram in order to make sense of what the definition is telling you. This is just a tutorial on how to actually use it. But the definition looks something like this. So we got y equals e, and in the exponent we have another function g to the x. So the definition, when you go take your derivative, is going to be g prime at x times e to the exponent of that function. We're going to call it gx right now. So what does that look like? Okay, so let's take a look here at this example. So y equals, well, I wanted an e and I was making a 2. So let's say e to the 2x. So what I want to do is I want to identify that gx, or g with respect to x, whichever way you like to say it. So in this case here, it's 2x. So we want to take the derivative of that. So g prime is going to be 2. So the definition says now g prime at x, so in that case it's 2. Multiply e to the exponent to that function gx. So basically what you're doing is you're multiplying it by that function you started out with. So looking at another one, let's look at y equals e to the x squared plus, let's say 3x squared. I can do better than that. Let's say 3x cubed. So again, identify g with respect to x. So in this case, it's all of this. X squared plus 3x cubed. Take the derivative of that. So that'll be 2x plus 27x squared. So now we want that. When I go to use my definition, it's going to be g prime. So that's going to be 2x plus 27x squared multiplied by that original function you were given. So e to the x squared plus 3x cubed. Those brackets are really important. If you write it like this, that's not correct. You got all the right parts, but it only looks like 27x squared is multiplying. So it's really important that you put those brackets around that g prime. So let's take a look at this. Oh, one thing I do want to mention, here's kind of one you're just going to kind of get used to and probably remember on your own. So if you have y equals e to the x, the derivative of that's just going to be the same thing. Y equals e to the x. And the reason, because your g at x is going to be 1, or excuse me, your g at x is going to be x, and your g prime at x, of course, is 1. So when you go to write it as a definition, it's going to be 1 times e to the x again, which is just e to the x. The more you do with these, the more you're just going to see y equals e to the x, and you say, oh, derivative is going to be y prime equals e to the x. And if you don't, then you can just go through this process and you'll get it every single time. So I want to look at an example here where, why don't we look at the product rule. So the function is y equals x squared times e to the exponent x. This is a product rule because you got two different functions of x trying to multiply. So we'll go to our 1, 2, 3, 4. 1 is x squared, 2 is the derivative of that, 3 is e to the x. 4 is a derivative of that, and I just went over that derivative of e to the x is e to the x. So again, when you're doing the product rule, remember it's 1 times 4 plus 2 times 3. So I like to do this, kind of line them up. 1 times 4, it's going to be x squared times e to the exponent x plus 2x times e to the x. Now again, that is a derivative, but we can clean that up a little bit. I'm looking through, and there's some stuff I can factor. Okay, look at x squared and 2x. Let me see if I can get my highlighter going. Good. So I can factor out an x is common there. And then I notice that both parts have an e to the x, so I could factor that out. So then I'd be left with x plus 2. So again, you always want to kind of look at that, I kind of like to call it obvious common factoring. If you have that opportunity, you should always factor that because that's not too bad there. Okay, so why don't we look at another example? Let's look at one where we're going to use a quotient rule. So y equals 2 e to the x divided by 1 plus e to the x. Okay, so 1 would be 2 e to the x. So derivative of that is going to be 2 e to the x again, because 2 is just a constant. So when you go to take the derivative of e to the x, it's just going to be e to the x again, so it doesn't really look like it changes, but it did go through the definition. And then 3 is going to be the denominator, 1 plus c to the x. And when we take the derivative of 1 is 0. And derivative of e to the x is e to the x. So remember the quotient rule is going to be 2 times 3 minus 1 times 4 all over 3 squared. So I'm going to set it up here. So 2 times 3, I'm going to go 2 e to the x, bracket 1 plus c to the x. And then we go minus 2 e to the x times e to the x, all over 1 plus c to the x squared. So again, we don't want to multiply out this bottom part, okay? It's not necessary, but I want to show you something up in that numerator. So I am going to expand here, and I can collect some like terms. Now, when I expand 2 e to the x times 1, that's just going to be 2 e to the x. When I do 2 e to the x, so I'm looking at this one right here. Let me just change the color here. When I look at 2 e to the x times e to the x, let me take a look at what that looks like over here. So you're multiplying, and the base e is the same. So that means that the base is the same, you're going to keep that base, and you're going to add those exponents. X plus x is going to be 2x. So the same thing's going to happen here. That's going to be a minus e to the x times e to the x. You're going to keep that base. You're going to add the exponents. So you can see here, this one's going to simplify. These two are going to cancel. And there you go. So if you wanted to find the specific slope of the tangent at a point, so let's say we want to find the slope of the tangent at x equals 0 of this function. So I'm going to go y prime at 0. So again, we're substituting 0 in wherever we see an x. So again, you've got that E button that you can punch in as a base, and you can punch in whatever exponents you might be dealing with. We're just dealing with exponent 0 here. So anything to the exponent 0 is going to be 1. So my slope of the tangent is going to come out to 2 times 1, which is going to be 2. So then down here, again, this right here, e to the 0, anything to exponent 0 is going to be 1. So I'm going to have 1 plus 1 to the exponent 2. So that's going to be 2 over 2 to the 2. I can simplify that to 1/2. And that is a tutorial on how to find the derivative of exponential functions.